Yeah, thank you so much, Anthony, and joining us today. Hope you all are having a fantastic evening. So let me just begin with sharing my screen. All right. So here we go. So let me just briefly introduce who we are. So I'm Suhas Hegde. I'm the Tech Community Programs Manager. And also I'm joined by Ernest, who's the Concordium Rust Advocate. We'll be walking you through some of the interesting things about Concordium. So initially, I'm going to speak a little bit about certain things about Concordium so that you understand how Concordium is different from the other blockchains and how you can build on top of it. I'm going to keep this very brief, and most of the presentation is going to be by Ernest, who's also going to walk you through certain things. So let's get started. So yes, like I mentioned, this whole presentation is divided into two parts: the presentation and the live demo. So live demo is mainly going to consist of an opening, basically an introduction to Rust toolchain, setting up Concordium standard library, and things like that. And also, you're going to have a walkthrough of the Concordium Piggy Bank smart contract and a breakdown of certain basic Rust programming concepts, which is used in the piggyback code base. And also, if you have any questions, you can ask us in the end or drop them in the chat, and we'll try to answer them as much as possible. If there's something that we cannot address immediately, you can join our communities and ask us questions there. We have a very great thriving community on Discord, a lot of developers there, so you can feel free to drop by and ask us questions there as well. All right, so let's get started. So as you all know, Concordium is a public permissionless privacy based blockchain. And the unique feature about Concordium is we have an inbuilt ID layer, right? And the way Concordium has gone about its approach is it hasn't been developing just on in an isolated manner, but also like there are various different verticals which complement Concordium, right? We have an internal science team who help us with the formal verification. We have the Concordium tech team, which consists of superstars. Our CTO, Tobin Pedersen, is the father of Pedersen commitment, which is used by many privacy protocols currently as well. And we also have many scientific partners like the Indian Institute of Science and many other great institutions. So some of the features we have here are identity primitives at the protocol level, like I mentioned earlier, which basically helps preserving anonymity and unlinkability. And we also have another unique feature, which is regulatory compliance by design. So this is an important feature because Concordium aims to serve a lot of enterprises. It wants to be the enterprise blockchain, but also at the same time, Concordium is a public blockchain. So the most important thing for enterprises is regulation, because enterprises do businesses across the world, across various jurisdictions, and regulation is an important part of that. Also, Concordium is fast, secure at the and secure. It has secure finality at scale. Basically, we have a very unique settlement layer, and hence, it makes a big difference. And we have a two-layer consensus design, which I'll briefly walk you through at a later point. And we are energy efficient because we use proof of stake mechanism. We already know how much of a carbon footprint, a lot of things are, all the proof of work blockchains are adding to, and Concordium definitely doesn't want to add to that. So a few things. So anyone can join the public blockchain like Ethereum, and but then there are certain massive drawbacks like I mentioned earlier, POW, and also there are regulatory issues, and also there's no privacy. If you're familiar with the Ethereum ENS, you'll know how much of a issue it is with respect to privacy, things like that. So Concordium plans to address various different pitfalls of various other blockchains. But also Concordium believes that the future is not going to be ruled by one single blockchain, but various different blockchains. And hence Concordium is building in that direction. And also a little bit about our groundbreaking breaking consensus mechanism. We have a two-layer consensus mechanism, which mainly combines the Nakamoto-style consensus blockchain along with the innovative BFT finalization layer for fast and secure and also reliable transactions. Also, the fee structure of Concordium is something very unique. You should look it up because we speak a lot about decentralization and things like that. But if you're familiar with using many different blockchains, for example, the Ethereum blockchain, you're seeing the gas is a huge barrier. Like not everyone has $100 or $200 to spend on a single transaction. So Concordium plans to address things like these. So Concordium reference products and tools basically consists of a suite of different products. Also, we have Rust-based smart contract support, and which compiles to the WebAssembly. And we also plan to support other languages in the future. So let's speak a little bit about what I mean by fast and scalable. Right? We have a two-layer approach that we take, and that basically ensures that there is no compromise on speed for security, right? Because generally, like we hear a lot about high TPS and things like that, but then it always comes as a trade-off with respect to the security or the decentralization. And when you're a public blockchain, you cannot have such trade-offs. You cannot have compromises with decentralization. And transactions on the Concordium blockchain are finalized and immutable within a short period of time. Which is really important for enterprises because enterprises need to deal with a lot of transactions. And we also have a novel sharding mechanism that's currently being worked on. And also we are secure and cost effective. Like I mentioned earlier, you don't want to have an entry to barrier because we'll see blockchain being used not only in the developed world, but also in the developing countries. So that's where we see a lot of adoption, a lot of population wanting to embrace this technology. And we believe that there should be no barrier to entry. So in our testnet, we extensively tested the stress. We stress tested the network and we had great results. So let me just play this video so that you understand a little bit about the stack. So we have the internet layer, the network layer, the consensus layer, and of course the execution layer along with the ID layer. And on top of that is the APIs, which connects to the use cases. So here in the consensus layer, we have sharding, the finality layer, and of course the Nakamoto style consensus. And of course the smart contracts and transfers happen in the execution layer and the ID layer. So this all together forms the whole stack. And that's how Concordium works. All right. So let's speak a little bit about the on-chain identity and compliance. So a user's identity is stored off-chain and remains private. So which means that even though it's a public blockchain, all of your data is very secure, and even Concordium doesn't know about it because it cannot be easily revealed as well unless there is a court order. So this is how we stay compliant when it comes to regulations. And of course, it's such a blockchain is designed for global operations, because a big barrier to entry for different businesses and enterprises is a lot of regulatory roadblocks and things like that. So by using Concordium, you actually get to apply the true freedom of public blockchains and decentralization. And it's easier for you to operate across various different jurisdictions because you're regulatory compliant. And mind you, Concordium is the only public blockchain which is a permissionless blockchain, and also complying with regulations. And a little bit about our on-chain identity system. Every user in the Concordium network is ID verified by independent third parties, and we use zero knowledge proofs for that. And also the identity system can be utilized by businesses and persons for all kinds of devices and products. And also the kind of information you disclose is flexible. So, we're not, you can just choose to share what you feel you're comfortable with. And every transaction is cryptographically linked to the verified ID object of the user, but it's undisclosed. And we also have adjustable account policies. And if you've seen our roadmap, you can also see that we have compatibility with various different, accounting softwares as well in the future. And some of the benefits of these business applications, basically identity at the protocol level, fast and secure. It's cost efficient, energy efficient, and also we have sharding, which means you can also run other blockchains on top of Concordium. So that really helps, scale, because again, we can basically have different blockchains who do different things, and then you can still run them and utilize consensus mechanism of Concordium. And of course, it's easy to use, smart contracts, Rust and WebAssembly, and again, regulatory compliance and things like that. So a lot of benefits. It can be used in many different industries, right from, like for your land titles, food safety and origin, insurance payments, the music industry, and, things like voting. Because things like voting is going to be a lot more easier because, we have an inbuilt ID layer as well. And for stable coins, of course, we are seeing the great applications that's been happening in the DeFi space lately. But then I'm sure that regulators are looking very closely at it, and Concordium can bring regulated DeFi. So, it provides a huge boost to the existing infrastructure, and as well, it might provide for various new innovative products that are yet to be developed. And of course, there's insurance and, of course, fractional investing, drug supply chain, and things like that. So the number of applications are ample. And as a developer, it's important for you to understand the ethos of Concordium, because a lot of people misunderstand that when you say enterprise, they think, oh, okay, enterprise means it's like a corporate coin or something like that, but definitely not. Concordium is a public blockchain, just like Bitcoin and Ethereum. But also it brings with it certain advantages. And as a developer, if you understand these advantages, you can build amazing products that's going to be used by millions, if not billions of people. And so a broad distribution model of Concordium. Concordium has this Concordium.com, and also there's going to be smart contract boutiques, and we have a great community. So all this comes under the smart contract and dApp developers. We also have the DevX Initiative, which is going to be huge. We are supporting the Rust ecosystem and support a lot of open source initiatives as well. We also have white label solutions for strategic partners, and also finalization as a service for private shards. Basically, you can have your own white labeled blockchain solution where your end customer doesn't even have to know that you're using Concordium blockchain for the finalization. Again, DevX Initiative, I think Ernest will speak a little bit more about it, and also watch out on some of the announcements that we'll be making. So this needs to be edited. DevX Initiative has already been launched. So over to my dear friend Ernest, who's going to give you an introduction to Rust and also the tooling available, and also run you through the smart contract. Ernest, over to you.
Thank you very much, Suhas, and thank you to all of the Encode team for having us over this series. Just before we get started, I do want to mention and share my screen about the DevX Initiative specifically. It's a very important part of the Concordium ethos. What Concordium wants to do is to be a part of the Rust ecosystem and to be embedded in the Rust ecosystem. It's not like a lot of other projects that you see where it's like, hey, come and build here. We've got the best tooling. We've got the best this. We've got the best that. Concordium wants to be seen as part of the Rust ecosystem and have the DNA of the Rust as part of the project. So I've seen a question, are there going to be hackathons and things like that? Yes, there will be, and they're going to be under the banner of the DevX Initiative. I'm just going to share my screen really quickly. Everyone with a GitHub account, please look for the DevX Initiative on GitHub, if you can see my screen here, and join the organization. This is where you're going to see lots of updates about what we're going to be doing in terms of hackathons, workshops, and specific events that are going to be beyond just Concordium as a project, but Rust based. So please make sure you look out for that. And it's going to be a very important part of the vision of how Concordium really engages with the developer ecosystem. So now I'm going to get into Rust as a language And I'm also going to be getting into a bit of a live demo where we showcase what you can do with Rust on the Concordium platform. So I'm just going to change my screen now to my presentation. Rust. So the Rust programming language in general is a systems programming language. It is a low-level programming language, or described as a low-level programming language. The core benefit of Rust is memory safety at compile time, but it goes beyond that. The Rust is a systems programming language that focuses on safety, concurrency, and speed, with its core vision being empowerment. Rust wants to empower individuals to write safe, fast code. Rust generally sits in terms of speed in between C++ and C. So when you've seen different benchmarks, it's actually as fast, and in some contexts is actually faster than C++, and even C in some instances. Rust is described as a mixed multi-paradigm language, meaning it has a lot of concepts from different languages, like Scala, C and C++, and even JavaScript. It takes a lot of the best components of these languages and really tries to distill it in one language that you can do a lot with. The story of Rust begins at Mozilla in 2010. It was a side project by a developer at Mozilla called Graydon Hall. They were working on the Rust as a side project and as a solution to some of the issues that the Firefox browser was facing with its C++ code base. Over the course of time, it became the predominant language at Firefox, and some of the core engine for Mozilla's experimental browser called Servo was actually rewritten in Rust with amazing results. It's now been open source, so it's now an open source language and project. And again, it employs the ethos that safety isn't optional when it comes to programming and creating your applications. What this means that it takes a lot of overhead away from the developer and allows the developer to focus on being more creative rather than having to worry about memory leaks and seg faults, because Rust as a programming language has features built in that just takes that away from you. Rust hit its stable version in 2015, and there are new features added every 6 weeks to the compiler. Rust in Concordium, and why Rust is a great language for smart contracts. So Rust is becoming and has been a very important programming language for blockchain in general. You see a lot of different projects that are either moving their stack over and rewriting a lot of their core protocols in Rust, or they're saying that they have the aspiration to do so. Some of the prominent new generation blockchains that are really going to make an impact that are using Rust include Polkadot, Nervos, IOTA. IOTA have just ported over a lot of their core implementation over into Rust, and Near Protocol. Concordium has, from the onset, had Rust as part of its core protocol and has now developed and chosen to have the smart contract language in Rust as well. And there are 4 key reasons why this makes a lot of sense, both from the developer experience point of view and for the integrity of your code. The first being the type system. Rust is a strongly typed language, but you get some of the benefits of a higher level language through type inference, for example. So, but the important thing is that you, under the hood, you know what your types are. At compile time, you know what your types are. And this is extended even further by Concordium's unique approach to their protocol, and again, the scientific rigor that's being used to develop the Concordium ecosystem. What Concordium scientific partners at Cobra and other partners are working on is actually extending the strength of the type system through formal verification. There's going to be a lot of really interesting stuff being done with that. And that is massively important when it comes to developing applications that deal with exchanging and transferring value around. When you're doing computation, when you're doing cryptography, you want to be sure that your types are what they say they are. You know, again, this is no direct attack, but one of the gripes that a lot of developers have with Python and other sorts of languages that are interpreted is that you just don't know what's going on under the hood. Because again, through Rust's type system and the way that things have been developed, you just have that assurance, and you know that you're not going to have issues like other hacks that have been or you shouldn't have the same sort of issues with hacks that have happened on other blockchains because of what you have with Rust at compile time. Another big reason is WASM. So WebAssembly is a binary file format. What that allows you to do is to write different bits of logic in different programming languages and have it compiled down into one binary file format. This is really important, not just for blockchain, but beyond, because of the ability to have the flexibility to use not just Rust, but other programming languages as well. Concordium have taken a really strong approach and embraced WASM as its execution layer because of specific benefits that Concordium have been able to craft into WASM. So into the specific WASM implementation that is used at Concordium, you get the well standardization and the determinism of WASM as an execution layer. So you know what you're going to get out at the end when your code compiles is going to be consistent and it's going to be correct mostly. There's simplicity and portability as well. The binary sizes are really small. So again, all of that is really important with how much consideration Concordium have taken to build out the protocol using WASM as its execution layer. And the tooling is what really makes Rust the best choice as a smart contract language and as a programming language for the protocol. WASM supports Go, Haskell, Scala. There are many different targets for Rust, for WASM, but Rust has the best tooling for WASM at the moment. So that's why, again, all of these considerations make developing smart contracts a really exciting proposition on the Concordium platform. Right, so getting started. We're going to see a little bit of this later on when we get into some of the practical aspects, but Rust is available for Windows, Linux, and WSL, Windows subsystem on Linux. Rust is installed and managed by a tool called RustUp. You'll see that when we go into the actual website itself. And as I said before, a new version of, or the compiler is updated every 6 weeks. So the stable version is already set in stone, but there are new things and new exciting features added to the Rust compiler from the wider ecosystem all the time. And again, this goes into the benefit of using Rust, because you're able to stand on the shoulders of the entire ecosystem. With a language like Solidity, for example, it's only ever used in the Ethereum bubble. Whereas with Rust, it's used in game development, it's used in embedded development, it's used across the board. So all of those different features and tweaks and advancements are all going into things that Concordium can utilize as well. When you install the Rust toolchain, you get Rust C, which is the compiler itself, Cargo, and Rusted, which is the standard library. To get started with smart contract development in Rust on Concordium, you have the Concordium Stud, which is a library, sorry for the typo, which allows you to write and test smart contracts on the Concordium chain. So you get to utilize a lot of the low-level operations that again are already there in the Rust language for the wider ecosystem, but you're able to utilize them for smart contract development. You manage your code base through a package manager called Cargo. So Cargo is what allows you to have repeatable builds. You don't have to have complicated make files or scripts. If any of you are JavaScript developers and Node developers, you would be very familiar with npm, which is the Node package manager, and Cargo was actually loosely based on npm, but with a lot of improvements because it was able to see a lot of the shortcomings of npm and actually improve that. So Cargo is the npm 2 for Rust, basically. For those who want to get into Rust, the first place to start is the Rust book. I can't stress enough how this is probably one of the best pieces of programming documentation that I've ever read. It's clear, it's concise, it's not pretentious, it's not trying to confuse you, because that's a big thing with the whole Rust ethos as well. It's about empowerment. So like, let's not make things overly complicated and gatekeep in that way, you know. The Rust book is made to be clear and simple, and again, it will really bootstrap you and get you up to speed with the programming language, and the core semantics of the programming language. You then have Exercism, which I use personally. This is an exercise platform, which has little examples that you can go through to get yourself up to speed. There's also another tutorial, a very popular tutorial GitHub repo called Rustlings, and also there's Rust by example. If you want to play around with Rust but don't want to install the whole tool chain, you can go to the playground here and start just coding with Rust. There's an extension to the playground called Explain, and this is the GitHub repo for it here, and this is basically the playground, but it has an extension that actually explains the syntax to you in a dialog box. So you'll be able to actually see what's happening as you step through the code. You'll be able to see explanations of your function signatures and things like that. There's also cheat.rs as well, which is a great cheat sheet for you to reference all of the different things that you want to look for. Tooling in the space as well is really great. There's Clippy, which is a linter, Rust format, which formats your code for you in an idiomatically Rust way, and Rust Godbolt for those of you who want to get really deep and start actually seeing the assembly that's generated from your Rust code. The community. I think this is the most important part of the Rust ecosystem, and again, it's jewel in the crown. I am a community lead in the Rust community ecosystem. I run the Rust London user group, and again, it has been so impactful actually seeing the community grow. If you want to be a part of the Rust Discord, I think it's imperative that you actually get involved and get in the mix. You'll find it such a welcoming place, and again, most importantly, very unpretentious. So there's the Rust Discord and there's the Concordium Discord as well. Again, don't forget the DevX Initiative GitHub as well. We're going to be releasing the roadmap with some of the key activities there. There are conferences as well. Rustfest is the big global conference for Rust. Look out for some Concordium members who are going to be speaking there as well very soon. There's also a RustConf, which is more centered towards the USA, but again, it's open to all. There's Cloud Native Rust Days, which is coming up as well. That is a cloud native focused Rust conference, and there's Rust Lab, which is another conference based out of Italy. Working groups and interest groups, very important, because again, these are accessible, and if you want to see what's actually being built throughout the wider ecosystem, get involved in interest groups. Again, through the DevX Initiative, there's going to be some interesting things happening with the Rust crypto interest group and the Rust form of verification interest group, because of all of the work that has been done by Concordium and Cobra in the background. It's actually being fed into the wider Rust ecosystem. So there's going to be some exciting things happening there. Rust Async, Rust Embedded, all of these, Rust Aerospace, which is quite a new interest group as well. So Rust in aerospace and drones and things like that. Check out all of these interest groups and get involved, because it's open to you to do that. And that is that. So again, really excited about Rust and the future of it. I'm now going to start to go through the practicals part of the session for the last half hour, and we're going to talk about the Rust Piggy Bank tutorial that comes from the Concordium GitHub repo. I'm going to find the GitHub repo and share that in the chat, so that those of you who want to check it out and try and follow along, you can do so. So just bear with me a couple of minutes. Thank you all very much.
Also, don't forget that we have, we'll take questions from the audience. So if you have any questions, you can feel free to drop them here, or even on our community. We also have some of our members from the tech team here as well. So yes. So I see Sarah asking, what is the difference between testnet and mainnet? So testnet is like the sandbox where you test the network, you see what features could be improved and things like that. And mainnet is when the actual network launches and it's being used for practical purposes. So yes, also I see Ernest posted examples there.
Okay. So I'm now going to share my screen in my IDE, and then I'm going to start talking about the Piggy Bank smart contract example. Right, so this is my IDE. Apologies, it's a little bit messy. And we're going to go through the tutorial that is available to everybody on the Concordium developers website, written in Rust, and I'm going to walk you through some of the basic components of it. First, let's start with the why. Let's start with the reasoning behind it. This tutorial asks you to build a piggy bank, so model a piggy bank on the blockchain. The piggy bank should allow anybody on the network to insert GTU, which is the native token of the Concordium platform, into it, but only the owner of the piggy bank should be able to smash it. That's the core purpose and the reasoning of the project. Once the piggy bank is smashed, it should not be possible for anybody, any person, to be able to insert any more GTU into the actual piggy bank once it's been smashed. So we're going to start the walkthrough by setting up some of the tooling, but I won't focus too much on that. What I'm going to do is I'm going to switch my screen and just show you the Rust website where you can install the tool chain. But because of time, I would have wanted to taking you through how to kind of do your environment variables and things like that. But there are guides and there are help. There is help on Concordium's developer website on how to configure your setup. So if you want to install Rust, you just go to or just type in Rustlang. This is the official Rust website, and you just click on Get Started. Once you've done that, it will take you to one of the configurations where you can install the toolchain for your specific platform. And then also you can configure your environment variables here. So again, this is pretty self-explanatory, and I'll allow you to kind of do that yourself. I won't go too deep into that. I'm going to head back into the code now and just continue explaining the actual piggy bank tutorial itself. So the first thing we need to do is we have here, this is what Cargo looks like in my side panel. Cargo again is your package manager, and it's how you manage your project. Whenever you create a smart contract in Rust on the Concordium platform, you use Cargo Stud, and you start with your manifest, your Cargo TOML. This is where you basically pull in any of your dependencies and you set up the basics of your package itself. In Rust, libraries are called crates. So that's the same thing. Crate and a library is the same thing. And you can either, you always start, you can either have a main.rs or a lib.rs. That is your entry point into for the compiler. That's the root of your package. That's what it's called, the root of your package. Going back into the code now. Before you begin, you have to import Concordium Stud using this import statement. And again, this allows you to leverage all the low-level operations from the Rust library itself. There are specific things tweaked for smart contract development, but you're essentially using Rust here. You're writing Rust as if any other person programming Rust would be writing Rust. Now, coming back to the next step, with the smart contract for the piggy bank itself, we need to first of all define the state of it. So we need to have something that tells us if the piggy bank is smashed or if it's intact. And to do that, we can use an enum. An enum allows us to define variants for state. And enums are very powerful in Rust. They're very powerful. They allow you to do a lot of really cool things in Rust. What we have above the enum is a procedural macro. This is something that is specific to Rust. It's a feature of Rust, but it's also been tweaked further for Concordium, so that we know what to do with this code on chain. What we're doing with this procedural macro is we're saying that we're going to serialize this code so that it can fit on chain. So we're declaring the basic logic here using an enum, but this procedural macro is like a tweak for the code itself for the way it will be handled on chain. We then now move on to, once we've declared what state a piggy bank can be in, it can either be intact or it can be smashed. We then need to create a function that generates a piggy bank, that initializes a piggy bank. And for that, we use a special type of function called an init function. This is a declaration of an init function. And if any of you are familiar with object-oriented programming languages like Java or C++, this is analogous to a constructor. So this sets the starting or the opening state of the piggy bank to intact, and it also checks, we're gonna look at that further, it also checks that this is correct. When we see how to test a smart contract in Rust, we'll be able to check that a piggy bank has been created correctly and it has the correct state on initialization. Again, all of this stuff is really important when you're dealing with value and things like that on chain. A function signature Rust begins with the keyword fn and then the name, and then these are the inputs of your function here. So what we're saying here is that this takes in a reference to a value that has context, and it returns the state. So this is how returns are declared in Rust. It returns the state of the value. So this is our initializer, our constructor function. We then want to now do things with the piggy bank once it's been created and we know that it's intact. We then want to do some stuff. Now, what would we do with a piggy bank? As we stated before, the original purpose of this is to have people insert GTU into it. So we have to create a function to allow people to do that. And what we do is we create what's called a receive function. Coming back to object-oriented programming, a receive function is analogous to methods or member functions in an object-oriented language. So once the init function has done its job, that's all it has to do. We then hand over the rest of the logic flow over to receive functions, and you can have any number of receive functions inside a smart contract to do the things that you want it to do. So here we have a receive function called Piggy init, and it has a generic parameter here to state that it has actions. It has some sort of actions. And this is a specific semantic and a specific syntax quirk with Rust that I would love to go into, but it can get quite hairy. We do have some of our team members here, if we want to ask some questions afterwards, that can expand on this. But this is basically a generic parameter saying that this function can take any kind of specific function here. There's more that needs to be explained about that, but again, just for the purposes of time. It has 3 inputs: amount, state, and context. State here is and these are the types here. So in Rust, you first give it a name and then the type afterwards. So state, for example, is of mutable reference to the piggy bank state. What that means is mutability in Rust, being able to change something in Rust, has to be done explicitly, which is actually a really good safety feature. Other languages like C++, mutability is on by default. That means state can be changed by other things in your code because it's always on. Mutability is always on. In Rust, it's the other way around. Things are always off, and you have to tell the compiler, and you have to tell the program which things should be allowed to be changed. Again, this is all really comes down to safety, and also comes down to your code being the integrity of your code. It being a reference to piggy bank state is also something that is quite a big topic in Rust. It's called ownership and borrowing. This is one of the key things that makes Rust memory safe, is the ownership and borrowing model. And again, there's more that can be elaborated about that. We will share some documentation, and we're going to be sharing some specific tutorials about ownership and borrowing for Rust specifically. But it being a reference is saying that it's borrowing the piggy bank state. So this insert function is basically, in a nutshell, what allows a user on chain to insert GTU into the piggy bank. We have a second receive function, which is again similar to a method for the piggy bank being smashed. Again, similar format, keyword function, the name of the function, a generic parameter, and then it has the inputs of the function, the parameter inputs for the function, and the return type, and the return type here. Again, with result and OK, those are quite deep topics to get into. But basically what this OK is saying is that, look, if everything has gone all right, if the function has initiated itself and done what it needs to do, it should, if everything's okay, you should get back these things, or you should get back these results. Again, there's a lot more to it. I'm slightly paraphrasing here, but that's kind of what result and okay is. It's unique to Rust, and it also gives the function a more expressiveness, because you're able to think of your functions in terms of results and outcomes. You know that if everything has worked okay, that this should happen, and that's unique for Rust. And it also factors into the error handling, and how error handling is done in Rust as well, in a very expressive manner. So here is a second receive type function, which is again similar to a method that should state that if the piggy bank is smashed, this is what it should return. Okay, how are we doing for time? Just looking at the time. I'm going to go through some of the testing suite now. Tests in Rust are written like any other type of application. Rust has an inbuilt test. Let me just check and see if there are any questions actually before I get into this. Okay, there's nothing specific about that. Okay, so there is a specific inbuilt test suite for Rust. And again, it's a very important part of what you do with your smart contracts development. Here we're writing a test function for, as I stated, the constructor of the piggy bank. We're testing to make sure that when it's initialized, that it has the correct state result. So it should be intact. And also there shouldn't be anything inside the piggy bank when it is created. And this is, again, you get all of this feedback at compile time, not at runtime. So I know I've said this a lot. I know I've probably gone on like a broken record about it, but this is really important to have this information at compile time rather than when you've deployed or at runtime, because you're able to fix stuff before deployment, before even runtime. You're able to fix things and make sure that you have correct code, that the integrity of your code is there, and everything works as it should do. This is the uniqueness of Rust. Rust isn't revolutionary in that sense. It's just that it's a distillation of all of the really good practices and all of the things that developers would have wanted from programming languages in the past, and it just works. So having a test suite in the actual language itself, you just use cargo test to do that with. And again, all of this stuff really does come into its own when you're in the process of developing stuff with big stakes. There is more that I can go into, but then we get into a couple of rabbit holes. So what I would like to do now is I'll stop here, because we'll still have like 5 minutes for questions or so about Rust, about the code itself. If there's anything more that you would want to see, or anything more that you want me to expand on about specifically, then we can do that. But this is pretty much what you get. A lot of people who have tried out our smart contract test suite, who don't have anything to do with blockchain, have really commented on how well it feels like just coding in Rust. You know, it doesn't have to be specific to blockchain. You don't have to know anything about blockchain to come into this. But if you know Rust, you can just come in and get bootstrapped and be up and running really quickly. So if there are any questions or anything else that we want to speak about, we have a few of our team members here, as well as myself and Suhas. Thank you very much.
Cool. Silas has done a very good job at smashing through the questions on here.
Okay.
Silas, I don't know how you want to handle the questions that have come in so far.
Yeah, some good questions, and yeah, if anyone has any questions, they can just open up here and ask us.
There is a question about dexes here.
Okay, maybe I missed that.
Yeah, there was an announcement made like what, yesterday, 2 days ago. It was yesterday, right? About a dev team who've started building on Concordium. Victory.
Yes. So there is a lot of interest, a lot of developers looking to build on top of Concordium, and DEXs in general, I think, is a very interesting concept, mainly because we've been seeing the success of DEXs when it comes to taking away the volume from centralized exchanges. And while that's a great thing, and while we all like that, there are still regulators who are worried about it. And especially with the tightening of the regulatory environment, I think eventually there will be some sort of legal implications for DEXs, and of course we do not want to let go of such amazing technology. And the only way forward would be to make sure that the regulators do what they do best, and the builders and developers do what they do best. So having a regulated DEX, in a sense, would be kind of cool too. So you might be wondering, if it's a DEX, then how is it going to be regulated? Of course, we can have regulation even if it's a DEX. Only thing is, it's not going to be. So yeah, and if you're looking to build such solutions, you can reach out to us. We always like to listen to the community. We take inputs and things like that. And who knows, maybe eventually someday Uniswap may use Concordium. You never know,
Cool. Thank you. Someone has asked, how long does it take to become a good Rust dev, and why should someone build on Concordium instead of Near? Well, okay, from someone who's actually going through that process, who's still in the the stages of that process myself personally, I would say it takes, you can't really put a hard date on that. I would say that once you get ownership and borrowing, once you get those two concepts, because Rust has been described as a language with a very steep learning curve early on. So getting into it, some of the semantics, some of the syntax, some of the concepts are difficult to kind of get your head around and wrap your head around. But once you hit that point where it all starts to click, then you fly. Then you start to fly. I've seen people again who have really been able to utilize the power of the language once you get over ownership and borrowing. Understanding the concept of ownership and borrowing, and how that's important for memory management. Again, you find that so many things click into place after that. If you're coming from a different language, if you're coming from somewhere like Python, or coming from another low-level language like C or C++, there'll be things that will be very familiar to you, but then you'll realize that, hold on, Rust does it in a different way for a specific reason. And once you're able to embrace the compiler as your friend, the compiler is your friend, always remember that, and embrace the borrow checker as your friend, then after that, you'll really start to see the power of the language moving forward. And okay, why should you build on Concordium instead of Near? Again, that's one of those questions where it's not really a either or. I don't believe, again, and just as Sue has said, there's not going to be one platform to rule them all. Like, it's not like Lord of the Rings or anything like that. Near has its benefits, but I would say if you want to build on a platform that gives you ID, because ID is one of the big challenges for any blockchain. And the fact that Concordium has centered and focused on privacy and ID, if you're going to build anything at scale, you're going to have to tackle with how you manage identity on the blockchain. And with Concordium making that its focus, again, it's just less friction. And then that allows you as a developer to do more cool stuff. So it's important to remember that every project, every different platform has its benefits and its shortcomings. But what I appreciate the most about Concordium is the fact that they've taken a very considered scientific approach. I mean, it's not a Professor Coin or anything like that, but it's trying to do things properly, you know, in a sense that it's not in the melee of a lot of other projects that you see on Twitter and all of the flame lords and back and forth. And it's trying to do something really innovative, but it's not trying to be everything. It's not trying to be, you know, everything to everyone. So I would say, look at Concordium if you want less friction and you want to know that like you can do cool stuff really quickly.
Yeah, and also we had two more interesting questions. I think Sierra is asking, I had some problems with the bugs in the Concordium testnet. Will they be fixed? Of course, if it's a bug, then it is something that will definitely be fixed. We even have a bug bounty program in place, so you can report it to us. And if it's actually a bug, then you can apply for the bug bounty program as well. And another question from JJ is, isn't KYC against the principles of blockchain? You're trusting, okay. So KYC is not really a problem. It's something we need to deal with, right? Now, I know it sounds like a great plan to have a world free of KYC, but then fortunately or unfortunately, we live in a world which is, we have societies, we have governments, we have businesses and various different entities that we need to live amongst. And the only way to rightly survive amongst these systems is to sort of abide by the rules of the system. And KYC is nothing but just a part of it. But of course, we do understand something like KYC, which is very personal to individuals, is something that needs to be protected. Unfortunately, things like identity are not being dealt with properly. We've seen the recent breach at Facebook and things like that. Facebook is such a huge company, but then we still see breaches and things like that, which is really unfortunate. That's exactly why we use ZK proofs. So your data is secure. Nobody else has access to it, not even Concordium. So the use of blockchain will not only help you, understand that your data is only yours, and it'll also give you the privilege of actually sharing what you want to share and with who. And this is an interesting concept because this leaves no space for any sort of harassment by third parties or anything like that. If there's identity theft by a centralized entity, then you know that it was misused here. Yeah, please.
Sorry, just to jump in and answer the question. Concordium isn't a private blockchain. It's not a permissioned blockchain. It's a public blockchain. So yes. Go to GitHub right now. You can fork the code. The code's open source, and you can start building on it. What Concordium's trying to do is actually revolutionize KYC. So KYC has been broken forever since its inception, and having the ability to really supercharge and make KYC more self-sovereign is something that's really going to change the nature of enterprise. So again, you don't need permission to join the network, to run a node on Concordium, to be a baker. There's no KYC from Concordium. If you, again, it comes back to, if you want to build something, let's say, for example, you want to build a DEX, right? You want to build a decentralized exchange for, I always use this example, but for sneakers, for really exclusive sneakers. You want to build a DEX for that, right? You can fork the code, build that DEX, but you have the tools in place to do unique things with the way people can access the DEX, the way people can be verified on that DEX, to make sure that what you're exchanging is not counterfeit because of Concordium's identity framework and layer. So it's, again, it's not a private blockchain. It's not like Hyperledger or anything. It's the opposite of that. But again, the tools are in place for people to do unique things with unique use cases, where privacy is concerned, where KYC is concerned in itself.
And also, like, I'll give you a small example of what KYC means, right? If you have a passport, then that is the KYC that's being issued by your government, and Concordium has nothing to do with that. An identity object is something that links you with your identity. So even that is very secure. So it's not like a barrier to entry or anything like that. And I see JJ also asking, you don't permit people to join without KYC. Yes, of course it's not exactly like that. You need to have your account linked with an identity object. The reason is always, like, even back in the day when everything was getting digitalized, regulation was a big issue. And if you see, our chairman Lars, he spoke about it. He was one of the founders of one of the earliest online trading platforms, and this is what he realized back then as well, that without regulation, you cannot deal with banks, you cannot deal with enterprises. And when we're speaking about serving enterprises, and when we're speaking about dealing with banks, you need some sort of compliance, right? Without compliance, regulators are not just going to allow you to operate. And hence, but also that does not mean that it needs to be at the cost of your privacy. And hence, we use ZK proofs, which is verified, which is something, that just didn't happen yesterday. It's cryptographically verified and something very legit. So we use this technology, make sure that your data is only yours. Even we don't, you're not exposing your data to us as well, and making sure that you're still compliant.
And the next question about who verifies the identity object, that's actually a really good question, because that goes into the network of identity verifiers, right? Where you actually create a whole new kind of cottage industry of people in a decentralized way. Do you want to talk some more about that, Suhas?
Yeah, so currently we have many identity providers who have shown interest. So Concordium, so there are certain trusted identity verifiers. Now, for example, Onfido is one of the identity providers. So they may be in your country. If you have any great identity providers, then you can ask them to get in touch with Concordium, and we can do that. Onfido is a private company, and okay, so yeah, so even so what if it's a private company? It does not matter, because your data is not still being shared with a private company. It's still, you're still using ZK proofs to make sure that your data is very private. So yes, it could even be governments themselves, if they want to become identity provider, they can. But of course, we cannot say who wants to become and who doesn't want to. But we'll make sure that the identity providers are legit. They are people of reputation. So yeah, and I say we, it means decentralized governance of the Concordium ecosystem. So there's no centralized entity who's dictating the rules or anything like that.
So I think, again, just another point to JJ. I don't think it's not just Onfido who would verify your identity object. I think the plan is to have a network of decentralized identity verifiers across the board. So if you don't want your identity object done with Onfido, you can do it with whoever else is within the Concordium network. Is that correct, Suhas? Am I understanding that correct?
That's perfectly right. Yes.
So again, it's about having a wide array of different. Those companies could be anybody. We don't know that yet. That's what is actually being developed. Some will be public, some will be private, but the point is there won't be one single entity that will be passing or verifying your identity object. The idea is to have a bunch of different identity providers, so that, again, if I'm a developer in wherever, right? Choose a country, and I don't trust my country's identity providers, I can go somewhere else within the Concordium network and have my identity verified, or my identity object verified by another provider. Again, the point is to have a wide array of decentralized identity providers who will be, some will be public, some will be private companies who want to do it as a service, who want to offer it as a service. So you as an individual can vet that identity verifier and be like, well, you know what, I don't really like this one. Let me see if I can find someone else who would be better for me or more aligned with what I believe. You yourself can become an identity verifier.
Yeah.
You can set yourself up as an identity verifier, and you're incentivized for doing so within the Concordium network. Again, that's what we're trying to get across here. Any more questions, JJ? Because I'm loving this.
Okay, so we can go on and on about, you know, identity providers and things like that. I suggest you go through our white paper. It clearly, you know, mentions a lot about this and also the technology behind that. And if you still have questions, you know, you can feel free to drop by our communities, and we'll make sure that, you know, you have a clear understanding of the same. And also another interesting thing is every week now we'll have a lot of AMAs with our team. So you get to actually talk to the engineers yourself. You get to talk to the team members yourself. So it's a brilliant opportunity for you to actually directly interact with the team on some of our communities. So yes, everyone's welcome to join that as well.
All good. All good. Thank you very much for having us. It's been a very great, it's been a very great experience sharing a lot of the Concordium's vision and ethos with you all. And
thank you guys for being here and for all your passion and enthusiasm. Was there another question?
No, I think they're going at it in the chat.
Let them go at it. We like. We've gone over now, so I think we call it a day there and continue the discussion on the Concordium Discord. Thank you.
Yes, please do. JJ, come into the Concordium Discord and we'll carry on.
Excellent. Well, Ernest, so thank you so much for such a brilliant presentation this evening, this afternoon, this morning, wherever you are, various attendees today. Thank you for joining us. This will go up on the YouTube and the Medium, and please do stay in touch with everything we do at Encode and Concordium separately for all upcoming initiatives. But in the meantime, Ernest, thank you very much. Thank you, everyone, for attending.
Thank you.
A pleasure, like always. Thanks so much for hosting us.
Yeah, thank you very much for hosting us.
Thank you for coming. All right, guys. Thank you very much. Bye.